Check if it's recording, but I think it is. Yes. Okay, good. Let's do the exam review. Several people asked which chapters we are covering, and we stop with 2.3. That's actually pretty classic to do it, even for in-person classes. They don't want you to go to hardcore differentiation in 2.4 for the test. So 2.3 is kind of the first basic stuff. The power rule, I mean, I'm not saying it's easy, but it's getting harder after that. So they don't want usually to put it on the test right away. It goes to the second exam and mastery exam. Most of the exam will have limits, lots of them, a little bit too much, if you ask me. So let's practice this. That's nothing to do about 5. Classical, this is from your homework. We copy everything from your homework. So some graphs, you will recognize them if you practiced homework. So like this graph definitely is familiar to you, I think. So from the graph, let's answer all of those questions. Limit from the left, limit from the right, and just limit. So in this case, -1. How to find limit as x approaches to -1? You don't know until you check left limit and right limit. You need to do that first. So the first one is from the left. I always teach in my classes that you should remember the English version. It's not left limit, but limit from the left, because then you will not do a mistake. Here is my number 1. From the left literally means the number is approaching -1 from the left. So x, let me write down here, x is smaller than -1. So that's the idea of being from the left. If you call it left limit, sometimes students think it's going to the left. That's why I don't like it. Well, on the x-axis, find -1, here it is. And then while I will use the same idea of kind of like energy going into the -1 from the left, while x goes to -1 from the left, f of x at the same time also goes somewhere, and it stops when x reaches -1. We know it never actually reaches it, but it points at it. So when x points at -1 from the left, the question is, what is f of x pointing at? It's pointing at something. The answer is, where does it point? What height is that? The height is 0. And that's how you kind of think about it. You see, it's not the dot. So it's 0 pointing at stuff, even if that stuff is not defined. So don't be bothered by that when it comes to limit. Now, from the right, the same idea, but this time x is greater than -1. So it goes, let me maybe change the color to pink, from the right. So inputs are larger than -1. If you wanted the example from the left, it was -1, 0, 0, 1. But from the right, it is -0.999, right? So x was smaller than -1. Now x is bigger than -1. That's how we're approaching from both sides. Okay, so that's what I'm doing. I'm approaching from both sides, in this case from the right. And while I'm doing that, the function is also approaching some kind of height and points at it. And you stop when you reach -1 in the limiting position. It's called limiting position. What height is that? Still 0. Put 0. Conclusion. It's left limit met the right limit. Limit at the point exists, and it's also 0. So basically, left limit and right limit need to be friends. If they're equal, then the limit exists and it's the same number. Sometimes it's even plus infinity and minus infinity. So just like friends, they have to meet. That's the idea. Now let's check something different. What if they ask you what is happening at -1? So write down this one. What is f at -1? That has nothing to do to limits and pointing at things. That only has something to do with where the function is defined. So let me erase all of that beautiful stuff. And I will just look at where it is defined. It's maybe not defined at all, but in this case, at -1, 0 is the open point, so we cannot claim it as 0. But then we found this point. This is what we have for f at -1. F at -1 equals 1. This height is given. So it is 1. And that's how you know for the future topics that the function is not continuous at -1. It has a hole. This continuity called a hole. Limit exists, but f at -1 did not give you the same number. So let me write down. Not, let me put it in red. Not the same. So that's why it's a hole, discontinuity called a hole, which is a removable discontinuity, and we ask you to remove it, to redefine it in your homework. Now, what else? Let's do one from the right. I'm going fast so that you can stop me and ask questions, but not being bored. That's kind of my idea. From the right, let's go faster. From the left first. I like going from the left to the right. I think this is a good order because it's natural, I guess. So here is my 1. Going from the left means 0.9, but going from the right means 1.01, right? So this is the idea. Again, x approaches 1 from the left. While it's doing that thing, f of x at the same time goes to that direction and stops when x stopped approaching 1 from the left. Where does it point? What height it is pointing at? And don't care about holes or whatever. It's just a height. It's pointing at -2. -2. Let's check from the right. While x approaches 1 from the right, f of x going on the graph, put the pencil on the graph, and points at some kind of height. The height is -1 in this case. It's different because they're not the same. The limit does not exist. They did not meet, so they're not friends. So the limit does not exist here. And this is called jump discontinuity because it literally jumped. The definition of jump discontinuity, left limit did not meet with the right limit. Interestingly, that in general, if you want to talk about what does it mean to have a continuous function, when you take a pencil, it must go through without taking your pencil out from the paper. The moment I have a hole, I have to take it out, put it back, take it out, put it back, jump, take it out, put it back, and so on. That's how you know that the function is not continuous if it has breaks. What kind of breaks? That's called discontinuity. So you will see this, I think, several times in the test. I think I can see they just chose the problems. I was given the test. I just checked out what's there. They just chose those problems from your homework with lots of graphs. Now, moving on is, everyone's stuck with this problem. I was reading the forum. Guess the value of the limit by evaluating this and that at -6. So they want to do it numerically. Numerically. In general, you know, the graph representation can be given 3 different ways. You will see it a lot in calculus classes in general. Graph can be given as a function. So this is what we had here, and we did not have f of x written. Now we have f of x written. It's this, it's fraction. So now we're going to do it numerically, algebraically, and sometimes it's actually data. That's where the data science comes in, or like Excel file. What is happening at 1 and 2 and 3 and so on. So you will see all of these cases, and we need to learn how to work with all of them. In this case, they want you to take a calculator and plug in. It is so boring, like these problems. I don't know, it's just so annoying. Also, the decimals matter, so make sure you give lots of decimals. So what I would do, well, you're supposed to plug this number and this number and this number. That's approaching 6 from the left. So they're dividing into 2 parts. From the right, and this one is from the left. So again, you can sketch the graph. -6 approaches from the left. It is x less than -6. But what is less than -6? It's the one in the blue color, -6.01001001. And then greater than 6 is from the right. Greater than -6 is what? -5.999. Anyway, you build this table, you plug the numbers, number one, and then you get the outputs from the left and from the right, and you're supposed to see the pattern. And the pattern will be some numbers. So what I would do, I would just like plug the last 2. We know that there will be a limit. It's not always the case that you have a limit, but the closer you get, the more pattern you see. So why not just to plug the last one, the most close ones to -6 and make conclusion from that. And then we did it in class, in my in-person class, and it worked. So I'm like, oh, I guess it's a good shortcut. So maybe just plug f at -5.999 and get some number. Well, it's going to give you some number. Then plug f at -6.001. And it also gives you some number. And then match them up to whatever decimal they want you to match. That's what I would do. So that will save lots of time. That's my point here. That's called numerical approach. -5.999. Yeah, I guess so. I guess it got cut off. You're right. The 999.9. You also can check the limit using the graph. If you graph this function, it's supposed to tell you what is happening at -6, which we did also in class. We graphed and it worked. The Excel applications are annoying. Those are super annoying. It's just too much calculation, but they want you to know how to use graphing calculator, including number stuff. I think graphing calculator can actually do matrices and input many, like Excel spreadsheet, inputting many things at the same time. So make sure you put like lots of decimals in your answer and make sure you match the decimals. So if this one was 0.537371, I'm just making this up. I actually don't know. And this one is 0.53739.123, then you know answer only whatever matched. And that's what we checked, the program accepts that. Because whatever you match, that's where they both approach at the same time, like so. The other decimal is called an error. So that's just kind of like a garbage left over from approximation, the error. Algebraically, people kind of stuck with that too. So let me show you that. You will use lots of these two formulas a lot. So maybe remember this. Just memorize those formulas. Remember. They will be a lot in calculus 1, 2, and 3. So the earlier you memorize them, the better it is. X plus y or minus y squared gives you square the first term plus or minus double product square the second term. That's called square of sum or difference. And x squared minus y squared is x minus y times x plus y. Those two formulas, you must know them. They will be everywhere. And one more formula, some people were talking in the chat about tricks, is cosine square x plus sine square x equals to 1. You'll be using that a lot. That means 1 is sine square minus, it means sine square is 1 minus cosine square, or cosine square 1 minus sine square. So you can find any of these by taking 1 minus the other guy.
I'm sorry, what was the name of those first two formulas called? You said one of them was the difference of squares?
Yeah, the second one was a difference of squares, and the first one square of sum or difference. You don't have to know the name. I would say just know how to use it. Yeah, but thank you for asking. So in this case, we're gonna use the first formula. Equals sine equals limit h goes to 0. Don't touch the denominator. So I teach the way I teach my class with steps. The steps is step 1 with limits. Actually, let me show you the steps. If you watch some of my videos, you probably know that I like using steps. Steps with limits algebraically. Step 1, plug in the number. What if we're overthinking and everything is fine when I plug in 0? If you get 0 over 0, so 2. If you get 0 over 0 case, well, that is not good. So you need to simplify. Simplify. And usually we're using these formulas to simplify or multiply by conjugate. Those are like 3 major cases. Simplify, you create common denominator. You use square of sum, square of difference, sine square plus square, and the conjugating. Third, plug in again. So, and then you repeat if it did not work. That's kind of it. Then you need to simplify again. That's a cycle. So in this case, let me plug in h equals 0 and see what's going on. I plug h equals 0 and I have 0 over 0 case. Not good. Then I go to the step 2. Step 2 is, I know that division by 0 happens because of this bad guy in the denominator. It's h. So it'd be nice to cancel it out somehow. Then I will do 3 And I will use the formula. Square of sum a squared plus 2ah plus h squared, like so, minus 3a squared equals, you have to keep writing limits or else, well, in the written exams, in person exams, we take points off if you don't write limits all the time. But nobody will be grading your work for the online classes. They stopped doing that recently. So I will be giving partial credit. I will go and check everything. Maybe you lost a decimal. Maybe you were right, but you forgot to put, some people do this common mistake. Instead of 2 squared, a squared, they do a2 because they forgot to click the hat thingy. So I give full credit for that, for example. Anyway, don't be bothered with it too much. Try your best not to make typos, but I will go back and read everything and give partial credit for many things. 6ah plus 3h squared minus 3a squared. Distributed. Cancel. Yay, looks better. Still not good enough. I still have, so step 3, we try again. I plug 0 and I still get 0 with 0. Not good enough. Step 2, simplify. More. H. I notice I can factor out h, which is amazing because if I factor it out, I can cancel it out and I will get rid of the bad guy. So I will have h, 6a plus 3h. Yay, bad guy goes away. Plug in again, hope for the best. 6a plus 0. Perfect. We finished. So can you do that on the tab? No notes allowed during the exam, unfortunately. No notes and no formula sheet. That is strict requirement by the school. They do it for all classes, even with business students, which struggling usually more with math classes. So yeah, that's very strict here. They have like high requirements and stuff. Here's the same, not the same. So are you guys okay with that? This is, I think, is the best one from all the limits. When you see square roots, that's when it gets hard, I think. I don't know, it's kind of just annoying to use square roots everywhere. So again, step 1, plug in, hope for the best. I plug in 0 and I get 0 with 0. Bad. Step 2, let's simplify. I don't see any formula to use. There's no square of some difference and stuff like that. So in general, you see a square root, you know what to do. The long thing, which is multiply and divide by the conjugate. So let's multiply by the conjugate. So my students ask me, what does it mean, conjugate? And we checked. Conjugate means it's the same thing, but with different sign. If it was plus, becomes minus, minus becomes plus. So I will multiply by the square root 5a plus h plus the square root 5a. And the goal is to create the formula x minus y times x plus y. When this formula is created, I will square the first term minus square the second term. And it works well because of the square roots. They will go away. But you cannot multiply by stuff just because you want it. If you multiply it, you have to divide. So that's the rule. Oh, my kitty came here. Be quiet, okay? Lie down. You're fine. So let's do it. Limit. H. No, you're fine. Lie down. You're fine. What's so needy? Go here. No. No, don't go on table. So fine. H. Square root plus square root. I don't bother writing them down yet because they're not important. The top is important. This first term, let's call it x. This second term, let's call it y, and perform the ritual. Well, I mean, the formula. Square x, 5a plus h, squared, means squared went away, square y, 5a. Boom, that's exactly what we want. Because now 5a minus 5a gives you 0. So limit this whole thing, h square root plus square root. Again, we don't use it yet, so I'm just gonna keep it writing. We have 5a plus h, no, plus 5h minus 5a. Cancel out. Why this is amazing? Because now h will go away. And we already know that h was a troublemaker, was the bad guy that was making denominator 0. So we're very happy about that. It will be 5h. h, the square root plus square root, goes away. The troublemaker is gone. We have limit 5 over, and this is actually, I'm going to write down the roots because now they are important. So it's going to be 5a plus h plus square root of 5a. Finally, we got rid of the bad guy and we plug in 0 into h. Remember, not everywhere, not into a and stuff. Maybe I put it in different color, but put it only there. So we're going to have 5 over square root of 5a plus square root of 5a is 2 square root of 5a. Let's check the chat. When you say the conjugate, I thought you was talking about the scary movie. I don't know this. Luckily, I did not watch enough scary movies, so I don't know this one.
Professor, quick question. Like the step before the 5 over 2 square root 5a, can we just square root the whole fraction to like get rid of the square root in the denominator? Would that still give us the same answer?
Square root the whole fraction. Do you mean rationalizing the denominator thing? 2 5a times 5a times 5a. That's what people do sometimes to rationalize the denominator. That's what you mean?
Yes.
Yeah, you definitely can do it, but like, why would you though? I know why you're asking. Because in the pre-calculus class, we're forcing students like crazy to rationalize the denominator. Yeah, we don't care anymore. Like for the next 2-3 years, nobody will ever ask you to do that. I would, like, to be honest, I wouldn't even simplify. Well, I mean, if it's 9 over 3, I guess I would, but even that is not required. This is a program. It wants you to type in, just get carefully plug everything in. Don't forget the parentheses and stuff like that. Yeah, thank you for asking. No need to do extra work.
So I'm sorry, just to confirm, on WeBeWork, it will accept that form right there, so you don't have to rationalize the denominator. Because your review had the other version, and I didn't understand the answer until like what you just said right now.
So if everyone curious, 5 square root of 5a over 2 times 5a. Oh, times 5a. That's what people do. So now it's going to be blah, blah, blah. 5 cancels out nicely. Stuff like that. Yeah, we don't care.
Thank you.
We don't care. I know that's what I had to show in case they were showing it. Over 2a. So I multiplied by square root of 5a both sides. No, so they don't care. To be honest, I saw that WebWork accepts 5 plus like 3. It will accept that kind of answer. You don't have to add things together. It will accept 4 over 2a. You don't have to simplify. So it's very nice.
Thank you.
We checked. So I promise you that I checked.
All right, thank you.
And if it did take points off, that will be rude, and I will put it back to 100%.
I will let you know. Thank you.
No, I will be checking everything for that reason too. This problem, do you know how to do this problem? It's exactly the same idea here with the conjugate again. So be careful. In general, you see a square root, proceed with the square root. Which means now I just gotta do it right away. There's no fraction, so what? I still don't like square root. So multiply by the square root plus 12x and divide by the square root plus 12x. And then many students ask, but like, why are we even doing that? It's limited infinity. This is infinity and this is infinity. Infinity minus infinity is 0. Yeah, surprisingly not. So very interesting, but infinity minus infinity is not necessarily 0. Some infinities are faster. My cat has a crazy funny zoomies right now. It's just very funny to watch. So one infinities are expanding or blowing up faster than another one. So it's like explosion of a superstar. versus atomic bomb. Okay, they're both exploding to infinity, but one is obviously faster than another one. And that's why you cannot claim that it will be zero. It's actually a really cool concept. In this class, you will learn 0 to the 0k. Like we know 0 to 0 times anything, 0 to any power is 0. But then also anything to the 0 is 1 if a is not 0. So then what's happening with this? Is it 1 or is it 0? We're going to learn that. And there was some cool concepts in that. Yeah, so be careful with this. In general, if you want to have like a classical what to do on the exam, I'm freaking out, multiply by the conjugate when you see a square root. It's 99% going to work. Yeah.
Professor, I have a question. So if it's infinity minus 0, would that be 0?
Infinity minus 0, exploding minus shrink is to 0. Yeah, that will be infinity, not 0.
Okay. Oh, infinity. Okay.
Infinity, yeah. So explosion minus black hole. Black hole is shrinking, I guess, if you could think about that. So that thing shrinks to nothing and disappeared, while infinity is still exploding. That's how I see it. But we're going to learn in this class that infinity times 0, that's the one that's interesting. Is the black hole faster exploding than a nova star? And that's what we're going to be checking, which speed is faster. So all of those are really cool questions. Okay, algebra again. Square root of 144x squared plus x minus 12x times. Well, I already did it, right? So let's just, I guess, let me just rewrite it again. Square root plus 12x plus 12x. Now we have formula. Let's call it a and b this time. So a minus b times a plus b gives you a squared limit x approaches infinity. It will be a squared 144x squared plus x minus b squared, which there is no square root there. So we're actually going to have 144x squared. And it's amazing. Boom, cancels out. But we don't forget the denominator now became ugly, which is fine. Why not? The denominator is 144x squared plus x minus, no, plus 12x. So let's be careful with this. It's plus, it's plus, it's plus. Conjugate, we change the sign. So what is happening here? Let's try and plug it in. It's infinity over infinity. Kind of like not very nice. So let's try to see what is doing here. Limit x at the top. Good. And then the square root of 144x squared plus x plus 12x at the bottom. X approaches infinity. Okay, then this is where it's getting interesting. The book teaches you to divide numerator and denominator by the x with the highest power, which is super time consuming. So I'm teaching it differently. You don't have to do it. You can do it the way you learn, whatever. Anyways, it's correct. So what I'm teaching is the idea of finding the speeds on each side and compare them. So the speed of the numerator will be x to the 1 speed. So I call it the leader. I usually say find the leader of the numerator, of the top. That's actually the 1. The speed of the denominator is kind of tricky. You need to find the fastest function at the bottom, at the denominator. The fastest function I see is x squared, and it's also multiplied by 144. But it actually doesn't have a speed of x squared. Because it's inside of the square root, it actually has a speed x. It's a 12x speed. So it's not the fastest guy. How about this x? It has x speed? No, it actually has a square root x speed. So we don't like that. That's already not fast enough. So we have another x speed. So we're going to keep the one I put in blue. It's actually legal to write down equal sign, when you compare polynomials, it's legal to write down leader over the leader. And the leader is the x with the highest power. So I will have just leader x, just the leader of the square root. So the square root has like a little tail over there plus x, but we don't care about that. So the leader is 144x squared. And just the leader of this additional piece, which is 12x, it's like standing there by itself. We're keeping it because it has the same speed as the square root of 144x squared as x approaches infinity. This might be a little bit tricky, so let me finish and I will tell you, and you can ask a question. Now we can simplify that. And when simplify, the square root was like the hardest part. So now I will have x over 12x plus 12x. That becomes limit x over 24x. As x approaches infinity, those cancel out and the answer is 124. So let me make some comments before you ask a question. This idea of finding the leader at the top and leader at the bottom only works at infinity. At infinity, polynomials are like comets, right? So they're following, so there's a leader at the head of the comet, and then there's a tail, and the tail can be anything. So it's going to be like x to the 5 plus x plus 10 thousandths. At infinity, x plus, let's see, plus, now x looks like plus, x, let's do x cubed, then it will be different. Everything follows the leader. So I don't need to look at anything else except x5, but it's only like that at infinity, which we call in the long run. That's one thing to mention. And another thing to mention, note, it is not true when 144x squared plus x is a square root of 144x squared plus a square root of x. That is not true. But it is true with limits. And that's why limits are so important. It's super boring when you learn them, but they give you lots of cool things to do which were illegal before, like dividing by 0. Yeah, let's divide by 0. With limit, it's possible because we're approaching 0 as close as possible, but we're never actually reaching it. And this is also a cool example. At 0, yeah, I can actually see and actually make this idea that a square root of 14x squared plus x. At infinity, I only gonna look at the leader. So I can put an equal sign. And that's why it's so cool. Limit gives us lots of cool shortcuts and going through the algebra easily. So square root plus x equals 0. Okay. What do you think about this? Or you do it the way book explains. It's kind of slower, and I don't like people stuck on the exam. It's just slow this way. Let me give you my examples on these questions. I think you will enjoy these ones. So limits at infinity are my favorite ones because the way I teach it, it's very much better to see it this way and much faster to work with them. I have examples here. Oh, okay, fine. I'll just write it down. Here are the more examples. Let me move away this beautiful other example. At infinity only. So example one more. Limit as x approaches infinity. If you have two polynomials and it's x to the 5 minus 17x to the 7 plus 35x squared minus 10,000 x, then like a 13x to the 7 plus 3x cubed plus pi for no reason. So at infinity, this looks horrible, but at infinity, it's your most favorite example ever. Find the leader of the top. Actually, I decided to hide it. Do you know what's the leader of the top here? Yeah, that's what I'm trying to show. Tyler is asking good questions, so I'm going to show that. I'll show all three cases. The leader of the numerator is not the very first thing. It's x to the 7, exactly. So let's make sure we keep everything in front of it. The square root minus 17, so anything is there should be kept if it's multiplied by x to the 7. Leader of the bottom, that one is more obvious, it's in front. So that's the cool part at infinity. Those are like two comets, and they go somewhere far, far, and they're competing with their speed. Both give you infinity, right? It's infinity over infinity case. So which one is faster? Maybe they have the same speed, which is true in this case. So at infinity, we legally can just drop everything else because those are just tails. They follow the leader. So why bother even asking them where they're going if we only need to ask the leader? Boom, cancels out. The answer is minus 17 over 13. If the powers are the same, then the answer will be the ratio of the leading coefficient. The ratio of the leading coefficient. Let me write down. The ratio of the leading coefficients. COEFF. Coefficients. If powers or exponents are the same. That means two comets had the same speed. The only difference was multiplying by rate. So now let's show you example. Let's be like what? Example 2. How about this one? Limit x goes to infinity. And then you have x to the 5 minus 3x squared plus x to the 13x square root of x. Why not? Plus pi x to the 20 plus 300, like the movie. C also looks ugly. Doesn't matter. It's fine. Find if it's polynomials and it's infinity. It only makes sense to infinity. At infinity, we only need to ask the leaders where are they going. So x to the 13 is the leader of the polynomial in the numerator. Pi x to the 20 is the leader in the denominator. So you legally can write down, and usually I skip the step. I just give you the answer. I usually write down the answer right away. So I teach my students to do the same, and that's why they are the fastest or the test in my class. So legally, you can write down the equal sign. They cancel out, and you end up to, well, they don't cancel. They simplify, and you end up to B. You end up with 1 pi multiplied by x to the 7. Review the power rules. Now what? So the thing is, I don't even write down anything on any of this. The thing is, I just ask myself, which speed is faster? The speed of the guy at the top or the speed of the guy at the bottom? The speed of the guy at the bottom is faster. Everything that means that the denominator blows up, that's official terminology, to infinity faster. Well, if you're dividing by the biggest numbers we know, we get the smallest number we know. That's 0. Or if you want to write down it carefully, which I usually don't, I see it this way. Denominator blows up to infinity. 1 over infinity gives you 0. It makes sense because dividing by the biggest number you know gives you the smallest number you know. You can even plug in here 100. What's going to be 1 over pi times 100 to the 7? It's like 7 times more of 2 zeros, adding and adding and adding. It's going to be freaking small number. It will be 0.000000314, you know. So you can always check. That is my idea. So I also so if they're the same, it's going to be the ratio leading coefficient. If the denominator wins, then you have the idea of the number over infinity. That gives you 0 because everything shrinks fast because denominator blows up. And the third example, as you can imagine, what happens if the top wins? So 3. Limit. Let me just write down a short one so we don't spend too much time on this. X to the 71 minus 5x squared. 3x plus 5. Well, definitely the top is super fast. There's nothing the bottom can do to win that. That gives you, that means the numerator expands faster than the denominator. You have 3 cases here and can be plus or minus infinity. That depends on the sign. So be careful with the signs. If it's minus over here, it will be minus infinity because minus infinity are huge numbers, but negative. So plus or minus infinity, or D and E, that's the one when you have to check what is happening at infinity. Actually, no, that's not true. The D and E will not happen here. So it's either plus or minus infinity. It's good. When you divide by 0, that's the one that is dangerous. So let me show you that one. And the one which is weird, so top wins, everything blows up to infinity. And the last one is where denominator gives you 0. So sometimes actually it's at infinity as well, which is like x to the minus 3, x plus 5. X goes to infinity. Denominator, let's not do this way. I think we did not learn it yet. X squared, x goes to 0. At 0, you see the denominator will shrink to 0 faster than the numerator. So you have number over 0 case. That's the one that's kind of hard. It's either plus or minus infinity or D and E. D and E happens when left limit did not meet with the right limit. Left limit did not meet with the right limit. And also, in this case, it's going to be a vertical asymptote, VA. So those are the cases. And usually I tell students this kind of interesting pattern. This is how I summarize it. And it's not official way of teaching it, but students really like it. So I also like it. What I teach is if n is a number. Oh, maybe I have it here. Let me see. I think I copied it somewhere. Oh, now I copied derivative. So if n is a number and you have cases like n over infinity, that gives you 0. Denominator blows up and everything shrinks. That just makes sense. If you have n over 0, guess what? You're dividing by the smallest number you know. You get the largest numbers you know. Plus or minus infinity or D and E. D and E. That's when you have the asymptote. And the left limit, for example, goes down and the right limit goes up. They do not meet. So that's VA, vertical asymptote, VA. That is also makes sense. Dividing by the smallest number you know gives you the biggest number you know. So it also makes sense. Then we have, say, infinity to the 5 over infinity to the 5. When speeds are definitely the same, you get the ratio of leading coefficients. Let's have an example. It's like 2 over 3, right? 2 over 3. Then the answer will be 2/3. The ratio of the leading coefficient. If the powers are the same, you definitely know they have the same speeds. Those are two infinities, but they have the same speed. Finally, two ones which are not that interesting. If you have 0 over the number, well, guess what? 0 over the number is 0. That's nothing scary here. Like 0 over 5 is 0. And you have infinity over the number. That's infinity. Infinity, if you have like explosion over a supernova divided by 3, guess what? It's still going to be explosion of a supernova. So that makes sense as well. So we have that. If you have 0 over 0, you don't know 0 over 0 or infinity over infinity, you need to figure out. So simplify, or use methods I showed you. That's when they compete. Does it make sense what I just said? I hope it did, because this is a very good way of, I like teaching this way. Students usually love this, but it only works if it makes sense. So here it is. So that speeds up a lot, lots of processes. Okay, let's see. I have left and right limit here. Let's do this stupid thing over here. People stuck with a 2. No wonder, because it's have fractions over the fraction and it's so easy to make an algebraic mistake. I'm checking the chat if you want to ask the question. So equals step 1, plug in, hope for the best. Maybe everything is fine. Yeah, it's not. So it's 0 over 0 case. Let's do something. You can also multiply by conjugate. Why would you do that? There's no square roots. In general, just try to simplify. And if you see 2 fractions, create a common denominator. So I usually color code everything in my notes as well, so I don't make a mistake. Highly recommend. at least use pencil and a pen. So now I know which fraction is where. Common denominator, multiply, then cross multiply. Some students call it this way. 8 times a minus 8 times a plus h. And now this is the hardest part for many people. How to figure out fraction over the fraction. This is how you see it. It has, let's create one fraction. H is in the denominator. So let's keep it there. And then a plus h times a is also in the denominator. So let's put it there. A plus h times a. And everything in the top. Let me put it in purple color. Oh, that's too thick. Will go to the top because it was a numerator. So let's keep it in the numerator. 8a minus 8a plus h, like so. Does it make sense? So that's where students get confused. I usually explain this way. We have a watermelon and we're dividing it in 2 pieces first. And then we change our mind and decide to divide more, say by 4 pieces. When what's the total division then? 4 times 2, right? Because I keep dividing. So that's why you should put all of this into denominator. Whatever says the word I'm dividing by should be together in the denominator. That's how I try to explain. There are different ways of seeing it. Now you distribute 8. I would take a pencil if I were a student. 8a and distribute separately. So I don't have to write all of it again and again. Minus 8a minus 8h. Now I just know that 8a minus 8a is 0. So what do we have? We have limit h goes to 0, 0. Did I switch between 0 and infinity? Yeah, that's rude. Don't do that. 0, 0. Minus 8h is left. H, a plus h, a. And it's amazing because h was a troublemaker and we were able to get rid of it. Plug in. I would not even rewrite it anymore because you can just plug it in. H equals to 0 gives you minus 8 at the top. Remember, h got cancelled out. And then I have a plus 0 times a squared. That's the answer. Box your interest so you'll be easier to find it in your notes later. What do you think about that? I'm checking my notes. Are you thinking I'm checking the notes? Oh, I wanted to show more stuff, more limits before we go into this left limit and right limit again and continuity. More stuff because again, exam is mostly about limits, so I feel it's good to show more limits. So one more example. Limit at infinity. Yeah, it's good as long as we remember the process. Exactly. You're right. It's hard to remember. There's so many things. At infinity, what is happening with like 7 cosine x? What is happening with sine and cosine at infinity? Okay, the limit does not exist. Just 2 ways to do it. A, just remember that. Sine and cosine in long run do not have a limit. And the way I can explain it is when you graph it, and we all know how sine and cosine looks like. Those are just waves. One is going up here at 0, that's cosine, and one is going through 0 but when it's sine. My point is, in the long run, cosine and sine are stuck in a tunnel from -1 to 1. In this case, it's multiplied by 7, so from -7 to 7, right? And it's keep going and keep going and keep going, minus infinity and plus infinity, forever. The thing is, it will never stop going up and down. And because cosine and sine cannot decide where to stop at 1.5 minus 0.3, not 1.5 of course, at like 0.7 at pi, cannot decide where to stop. That's why the limit does not exist. I just recommend you to remember that. If you see the example like this in exam, just it doesn't exist, okay? That's it. That was good. Like the best example to have if you remember what it is exactly the case here. Now let me ask you about this one. One more example with limits, and we can go on to stuff. Limit as x approaches infinity. It's the square root of 5x squared plus 25 over 9x plus 6. Can you give me the answer right away? So again, the book tells you to do it a very long way. I'm telling you to do it fast because it's the best way to do it on the test. You have more time to go back and check everything. If you finish the exam early, don't submit it right away. First of all, read and watch the video how to get 2 attempts. But in general, you think you're done? No, you're not. You don't submit it. Go back and check everything first. Maybe redo some problems you are not confident about. And I don't recommend checking your notes. I recommend taking like this problem we just did, not looking at your own solution and redoing it again. When you make a small mistake like losing minus sign or plus sign, usually you don't redo this mistake second time. So it's hard to catch mistake, but it's easier to not to make it. But don't run out of time. I think the web work doesn't like when you're running out of time, then it doesn't record anything. So don't stay longer than 2 hours, basically. Submit before 2 hours. Do you know how to do this one? When I was blubbing, the leader of the denominator is 9x. That's the obvious one. The leader of the numerator is 5x squared. Again, we're at infinity, so we can do that. But it's inside of the square root. So we have square root. So I'm looking at the leader. I'm like literally ignoring. I use this in the class. I take my hand on a screen and I cover up extras because they are extras. They are tails that following the leader. So I'm staring at this without rewriting it. And I'm like, wait, isn't it square root of 5x over 9x? Well, they have the same speed. If they have the same speed, the answer will be the ratio of the leading coefficients. So the answer will be this, square root of 5 over 9. Boom, you're done, move on. That's how good it is. So I really like this method. Good job, Tyler. Very good. Yeah, and then just be careful with the signs. If it's like one of them is negative, then guess what? It will be negative also. So just to make sure you understand that. And we have examples like this in your homework. Remember, it was like plus and minus infinity. So I wanted to show that. Examples like this. I actually decided to prepare it, show you. Oh yeah, someone posted it in the forum as well, so it's nice to show. It was plus and minus infinity. Let me find, here it is. Here it is. So example, that's now too thick. Example, yes, not only x can go to infinity, x can also go to minus infinity, which is far, far to the left, like this example with cosine. X can go to far, far to the right, plus infinity, but also x can go to far, far to the left, minus infinity. If you think about time, it's like going to the future and going to the past. So that's the idea here. Then you're working with fractions, and you have like 7x plus 13.5, and you have 25x cubed plus minus 7tx plus 10. Do you know the answer of this one? Like fast. Do you know what's going to be? You find the leader of the top. You find the leader of the bottom and compare their speeds. The bottom wins. So you're dividing by infinity, which is dividing by the biggest numbers you ever know. Try to divide by 1 billion. The answer will be very, very small. The answer is 0. But what is happening at minus infinity? Is it different? I don't know. Let's see that. They even decide to use the same thing. So you don't have to copy it. I will copy it to have good notes. I will share with you all those notes. And yes, the video is recorded and will be recorded. It's already recording, and then it will take probably 2 hours to video to finalize. And then I will post it when I receive the link of the video. At minus infinity, you still find the leader of the top and you still find the leader of the bottom. The difference now that x cubed now goes to minus infinity, because minus infinity cubed is minus infinity, while minus infinity squared is plus infinity. So now we're dividing by huge and negative numbers. It's like dividing by 7 and then 25 times minus infinity. Don't write this down. Nobody write it down with it. Well, dividing by huge and negative numbers gives you 0. You can try again. Yeah, you can plug in if you want. Plug x equals even 100 will show you that the answer is 0 or something close to 0, right? And in this case, you plug minus 100. So you plug huge number, but small. And the answer will be 0 as well. So if you hesitate, you can actually just check. That's to check. It will be close to 0. So it will be 0.0000 whatever, 17. I don't know what. In both cases. If the answer is indeed negative, it will let you know when you plug in those numbers. Jeremy is like too many tricks. So it's too complicated.
Quick question, Professor. If you go on to the previous example that we did where it was the square root of 5 over 9, when I was looking at your trick, my first thought was that the answer was going to be 7 over 25 based on the lead. Why isn't it in this case? Like why I'm not understanding why it's 0.
Oh, you mean this one?
Yeah, why can't we use the same trick?
Yes, so we did. So we did use the same trick. And then if you check these notes over here, only if the powers are the same, you can take the limit, the ratio of leading coefficients. But if one power is higher than another one, we have one of these cases. So it was x to the 1 over x to the cube. That's it. The denominator just blows up much faster. Then the numerator behaves slower than denominator. So it kind of behaves like a constant if you think about it. If you're hesitant about this, let me write down one step and you will be like, yeah, that totally makes sense. This step is legally we can write down only at infinity. A leader over the leader, 7x, 25x cubed. Check this out. It will be limit, simplify x, and x cubed. It will be 25x squared. Boom. The denominator blows up to infinity and the numerator 7, 0. So if you're hesitant, you can actually write down this little note. Yeah. Very good for asking. And it's also like they're small things. Those small things, you did not notice them. If we did not notice them, and then we're wrong. So now let's see. I wanted to go to derivatives, but let's do this thing. Yeah, let's do that. That's going to be important. Again, piecewise functions. So here's a function. It's a piecewise function because it's created out of pieces. And let's work on this function. They're asking what's happening at 8. What is happening from the left? What's happening from the right? And what is happening at 8? Okay, let's check this now. Let me check my notes. Here they are. So this is how I teach. The way I explain these things are very good. You can watch my videos called piecewise functions. And like and subscribe. No. The way I'm teaching is really good. I find I understand why students don't do well with piecewise functions because it's visually not pleasant. And it's hard to understand what the heck is happening. So what I'm doing is I'm gonna number function number 1 and function number 2. And there's more, and then a number more. And then I'm visually trying to understand what is happening. I can see something weird is happening at 8. Here's my 8. Now my goal is to find out what is happening before 8, after 8, and at 8. So I'll be using different color for number 1 and number 2. Number 1 function is happening when x is less than 8. So all of this part uses function number 1. Number 2, maybe let's put in this color, is happening when x is greater than 8. So here it is. This is number 2. And now the question is what's happening at 8. We'll find where this little piece is, which means greater or equal. And that's how I know that at 8, it's also function number 2. How does it connect to the limit? When I'm looking at the limit, the first one is from the left. I'm following the same logic I did in the very first example. From the left means x is less than 8. That's what it means, from the left. Those are two ways of seeing it. Either you actually find it in the list, here's x less than 8. Or you look at my sketch. From the left at 8, it's here. I like using this kind of approaching wave notation, but you don't have to. From the left means I'm going from the left of 8. What number did I put there? Number 1. So I'm using function number 1. But you also can just use this idea that x is less than 8, and then it's where number 1 is. So it means A is calculating the limit as x approaches 8 from the left at the function 4x minus 4. And now you just plug in 8. You completely ignore this little thing here. That's notation. It says with plugging 8 from the left. But when you plug it in, it doesn't matter. So you're plugging 8 minus 4, which gives you 28. Wait, 2 minus 4, 28. Somehow when, do you know that if you learn tables of multiplication in different language, it sticks with you forever in different language. So I never can multiply 4 times 8 fast in English. I have to figure it in my language first and then translate it back. I ask people in other languages, they do the same thing. Funny. 28. And then the same logic was limit from the right B. Limit x approaches 8 from the right. I don't know what's to plug in here, so let's think about this. 8 from the right means approaching 8 from the right. And it says use the function 2, so I'll be using the function 2. Or you can see it this way, x is bigger. That's completely, and my colors are all around the place. 2, x is bigger than 8. And we can see where it's bigger than 8. The second function. So the second function is 3 over x plus 9. So basically function is f of x is glued with using 2 functions. First function and a second function. So in this case, I'm looking at the second function. And it's 3 over 8 plus 9, which is 3 over 17. Well, we can make a conclusion. Let me put it in the table. 3 over 17. Limits did not meet it. So if they ever asked about a limit in general, which they actually never did, f of x does not exist because the left limit did not meet with the right limit. So it means they're not friends, and that means there's no limit. That's how you do it. And the C question has nothing to do to limits, nothing to do to that. C question is actually asking if you understand how to work with the piecewise functions. It asks what is happening at 8. So now you need to know where to plug the freaking 8 to the number 1 function, number 2 function. That's where this little thing will be so important. It can be anywhere or even nowhere. Sometimes it's not anywhere. Then you say D and E. If it's not anywhere, then you say not defined. But it is there at the function number 2. So let me put it again in this color 2, because we already talked about it. It is in function number 2. Then I'm plugging it 8 into 3 over x plus 9. And we know that the answer here is 3 over 17. That is the idea. So it's a jump, by the way. If the left limit did not meet with the right limit and it's not infinities, that's a jump. From the left, the height was 28, but from the right, the height dropped down to 317. So that's how it's literally jump down. D. And x equals 8, the function has a jump discontinuity, remove discontinuity, infinite discontinuity, circle 1. Oh, that's from my quiz, now I remember. Well, it is jump discontinuity, now you know. Explain why it is. Because BC means because left limit did not meet with the right limit. That's if you want to explain why it is jump. Jump is the official terminology. Jump and the whole and the infinite discontinuity, just like it says here, shows here, are official terms for 3 types of discontinuity. There's a 4th one, oscillating discontinuity, which we don't cover in this class. That's when the function wiggles so much that it never stops. Then there's also no limit. That's actually a pretty cool example. So that's what I wanted to show you. And after that, I wanted to move on to the derivatives, well, at least basic stuff of derivatives. Let me check if I wanted to show something more. Ask questions also. While I'm checking, I wanted to show So I showed lots of limits for sure. I think you will do good. I showed everything. Did you see in the homework, it says, one of the homework problems saying, now for fun, try to graph f of x. I'm like, this is not what I would call fun, but okay, sure. I was like, yeah, it doesn't sound fun to me at all. Oh, do you know how to do find this find c at which the function is continuous? Do you know how to do these, guys? Because that's also like classical. Probably should show you that. It's not very hard if you know how to do it, but it is hard if you don't. Well, actually, I can say it about anything, I guess. So it's 1.5. Then they give you a piecewise function. Let me find here. 20. It's 20 in the review. I thought I have it here. No, that's fine. 20 in the review says the function is given as dx cubed plus x when x is less or equal than 2. And it is 5c minus 3x as x greater than 2, like so. And then they ask find d for which, think, what value of c? Okay, I lost my point. For which f of x is continuous everywhere. So it's continuous everywhere. And they're like, wait, so find the c where there's no break or gap or hole. Do you know how to do this? What do you think? Do you think they're hard? Well, I will show you no matter what you say, but just kind of curious. Let me see the chat. Can also discuss how to know if a piecewise function that uses trig function is differentiable. Oh, okay, sure. I will do it after that. Maybe find me the problem from homework, Tyler. Then I can like go over the exact problem. So let's see, solution. So yeah, this is a good problem. We like to put an exam even for the in-person classes. Exactly. Michael says make two equal to each other. Yeah. So in order for a function to be continuous, oh, maybe you should review that, right? By the definition, f of x is continuous at the point A if and only if, actually. So IFF is a notation of if and only if. That means it goes both ways, which I will explain right now. We find that the limit as x approaches A exists. And to find that limit, you need to find left limit, right limit, and make sure they're the same. Then, let me not put equal sign yet. Then we find f of A, and it gives you some kind of number, and they should be the same. So there are 3 steps here. Make sure that the limit exists by finding left and right. Make sure f of A is defined, and then it should be the same number, because if it's not, maybe the whole. So if and only if means when this happens, the function is continuous, and when the function is continuous, this happens. So it goes both ways. That's what it means to be if and only if. And only in American notation has IFF, which I like a lot. So steps. I would start with checking if we have f of 2, well, we kind of know that, actually, let's just do the way you guys know. I think it should not overcomplicate for you. Like you said in the chat, let's just make left side equal to the right side using limits, right? So I will check the limit as x approaches to, from the left, f of x, and I want to see if it equals to limit as x approaches to, from the right, f of x. And then you know what's going on. You're using function number 1 and function number 2 for x from the left and x from the right, because it's exactly what it means to have those limits from the left and from the right. So D, and you plug in your 2, because that's what we do with limits, right? 2 cubed plus 2, is it equal to 5c minus 3 times 2? We just need to make it equal to make sure, you know what's going on here? Left limit looks like this, right limit maybe looks like this. We want to make sure they meet. That's why we put the equal sign for the c to make sure that they meet. And it's still maybe they meet at the whole. So that's why this is the one more step after that. So for C, so it's going to be 8C plus 2 equals 5C minus 6. 8C minus 5C3. C equals minus 8. C equals minus 8/3. Let me know if I made a mistake. So, and then actually you're checking if at this C, it should be second step, but you all know that usually that's it. Usually you can plug this as the answer and you're fine. But actually that's not enough. What if there's a hole? So you need to check this right-hand side property. Right-hand side property says, well, f at A, is it the same as limit? But I'm not going to do it. Let's not spend time on this. At 2, so we're talking about 2, and then we have this f of x, and it should be the same number. But you know, that's it. It's correct. If you want to find a C, you found the C. It exists. Put it in. Don't simplify. Yeah. Mute myself. Good. Make 2 equal. Yeah, so that's good. Now you know how to do the. Now, I wanted to show stuff over here. Let's see, the derivative stuff. Let's go there because I'm afraid I will not show anything with derivative. And I usually don't sit longer than 2 hours. I want to be done before 2 hours long period. What I want to show was this PDF. Where's my beautiful PDF file? Here it is. Limits. But now they're connecting to derivatives. So we're going to 2.1, 2.2, 2.3 material. To be honest, again, I will let you know most of the stuff on the exam are limits because limits and continuity, because derivatives will go to the next exam. Yes. Okay. You can email me, Tyler. Email me the screenshot to my email. Someone trying to talk? No. Good. So they connecting the idea of, oh, did I? Oh, I'm the one who is making the interaction of volumes. I see, it glitched. I thought it was someone talking. Derivative of x now has connection with the limit. And what kind of limit was that? It was x plus h minus f of x over h. H goes to 0. This is what we're having here, which is actually a very deep idea. I know it's really annoying, especially if you know how to differentiate, but they ask you to use this. But it's kind of important. So what they're saying is it's change in output, rise, if you want that. I like using the words output and input, output. So f of x, right? We're dividing by change in run. Rise and run is only American notation. That's why I'm not a big fan of it. To be international, I like to call it input and output, range of domain, x and f of x, right? So change in rise or change in run. See? A small change. H is small. Well, I don't have to write it down because it's literally going to 0 over here. So we have small change of output over small change of input, and we're checking what's happening here. Well, let's do it. I will show you how to do it. Most of it is like very annoying algebra. 34 says find derivative of 5 over x. If you know how to take derivatives, you just do it fast. You just do because you know how to do it. We want to rewrite it as x to the minus 1, and it becomes minus 1 goes down, 5x to the minus 2. This is the correct answer. You can rewrite it as a fraction, but actually you don't have to. So both are fine. But if they're asking you to use a definition, then yes, we're going to do that because sometimes they actually do ask you to use a definition, which is super annoying. Steps. If you want to do it by definition, which I just write down, let's call it star. Definition star. Definition of the derivative. Step 1. I like showing the steps because then people do less algebra mistakes. Step 1, find f(x plus h). You don't find it, you're just writing it down. So how to do it? The original function, let me maybe write it down. F is 5 over x. So keep staring at this function. That's important. Like stare at it as long as possible, so it makes it very clear what is happening. We were doing today it in class, and students just did not understand it well. It's always hard at first. Your input, your old input was x. My new input is x plus h. So wherever I see x, I'm going to put x plus h. So it's going to be 5 over x plus h. So your new input got changed. Your old input got changed to your new input. So this is what we have now. That is the first step, this one. Continue. Second step, you write down the difference, which is a numerator of the whole formula. F of x plus h minus f of x equals, well, you already found f of x plus h. Let's write it down. Minus the original function, like so. Now you completed the numerator. Step 3, write down the fraction. The fraction that has h in the denominator. So you're going to put this beautiful thing in the numerator. 5 over x plus h minus 5 over x. Simplify it, because we will have limit when h goes to 0, and we did this before. We did this before in different example in this review, right before this. Create common denominator. I'll go fast. Create common denominator, which is x plus h times x, and the top will be 5x minus 5 parentheses x plus h. Then you put denominators together. It will be h and x plus h times x in a denominator. And the numerator simplifies 5x minus 5x minus 5h. Nice. The goal is to get rid of h because it gives you division by 0. It's a bad guy. 5x minus 5x goes away. You have minus 5h over h, x plus h times x. Oh, almost there. Cancel out, and this is what you have. Minus 5 all over x plus h times x. That's what we wanted. We wanted to get rid of division by 0. What kind of division by 0 I'm talking about? Well, there's a limit happening. The definition of the derivative, 5 over x prime, is given by a formula. Limit as h approaches 0. If you want to write down the formula, first write down h. It's easier. And then you have f of x plus h minus f at x. And that's what we are doing with all those 3 steps. Step 1 was to find its first term. Step 2, find the numerator and simplify it. Step 3 was to simplify it. Step 4, write down the formula. Let me put it in some kind of beautiful box. Here it is. And now we already know the simplified version. Limit h goes to 0 of the simplified version. Let me put it in the box. Minus 5x plus h times x. Plug in h. Make sure you know where to plug in things. Come here. Don't be crazy, little cat. Slide down. H is 0, not x. So it's going to be minus 5 over x squared. Wow, it's the same answer we had before, but like half an hour later. So this torture, the redefinition is happening only in America. You can ask anyone who came from Europe or Asia. We don't do it this way. Here, they just really like this torturing through the definition. And it's always on the exam. We have to spend time teaching it. Students don't do well with algebra. So it's just a thing. It's just a local thing. But it is there. That is taking derivative by the definition. But then after that, we gave you formulas, which make life so much easier. So the question is, why? Why not just to do the easy way? Right? Like, people know the formula, they never go back. to the definition. 2.3 is amazing. Number 43 from the exam review. There's an exam review I posted in modules, and it's also on the official website of ASU. I also posted this. All the links are in syllabus. I'm very good at making very organized material. So I organize it well. It's in syllabus and in modules. When they ask you to find derivative of things like this, now you know that you don't have to do it by definition. You just use formula. Power rule. Power rule says x to the n. If you take derivative, n goes down, and x now is raised to n to the minus 1. That's it. The only problem is how to do it when it's 1 over x. So before taking derivative, let's rewrite it. 100 plus 5x minus 1 plus 40x to the minus 2 prime. If prime is still there, then we did not take derivative yet. So we were just preparing everything. And now you take derivative. Derivative of a constant is 0. Remember, C prime is 0. Why? Derivative asks the question, how fast something is changing? Well, how fast constant is changing? It is constant. So derivative of any constant, pi, e, 100, it's 0. It's a constant. So you know there's a name, Constantine, right? So the name actually translates into being constant, being stable. 5 becomes minus 5, x to the minus 2. Minus 1 goes down, multiplied by 5, and the power decreases by 1. See, that's minus 1, no matter if positive or negative. Minus 40 times 2, let me write down right away, 80 x to the minus 3, not minus 1. So we're decreasing the power. Can you do that? Is the metric math or something? Funny. So funny jokes. But this is the idea here. You can type it. Oh, the question. I think Tyler should ask the question. He asks good questions. Should we simplify it, rewrite it as fractions or not? Yeah, it doesn't matter. So you can type it like this carefully. Just put parentheses around when you type it in to make sure you don't mess up. Or you can it's not simplifying, actually, just rewriting. It's this answer is the same. 80 over x cubed. Doesn't matter. I would just write down the previous version. Whatever you got, just write it down, move on. So that's important. Finally, let me show you. Let me check. So the module 2 is on exam. People who are asking about what's on the exam, check the announcement. Announcement called exam 2 information. Actually, I have like 3 important announcements. What is on the test? Another announcement, how to prepare for the test. And another announcement, how to take the test carefully. So, yeah, also syllabus has all the information. But this is what covers test 1. Test 1 covers up to 2.3. So what I was trying to say. Oh, the other announcement, how to take the test, is extremely important. You might be amazingly prepared for the test, and then you accidentally close the program. You have only one try, okay? So don't like do something weird, or you forgot to log out from the laptop, tablet, and now you take the exam, it thinks you're cheating from your phone and blocks you right away, and you get 0. And then you try to prove you did not cheat. So don't do those things. I put lots of information there. I know it will be hard, but read it carefully. How to take online exams using honor log and web work, and how to get 2 tries.
Professor, really quick. You mentioned the logging out of the tablet and the phone and the laptop, meaning from Canvas, right?
No, web work. Web work.
Oh, web work. Okay.
Web work has a cool feature that if you're entering web work while you're taking the exam from any other tab or any other device, it records it. And actually they can give me, sometimes people try to cheat from the phone. They give me this, what's called report. And it says you entered from Apple while you're taking exam. It literally has numbers. When you entered, how you entered, it immediately gives you 0. So that's a game over, basically. So don't do that. But we had a case when the person was waiting for emergency hospital call for the relative. She grabbed the phone and she warned me about it, and I allowed her to grab the phone if that phone happens. But she did not log out from the web work, and it immediately logged her out and cleared all the answers. Everything was cleared up. So you have to be careful with it. Or there was a case when the kid was playing with the phone and there was a web work there. that also counts as cheating. So that's it. Like someone got into your web work during the exam, that's you're done. So that's exactly what Clark says to you. How to take the test careful, okay? Don't mess it up. 2.1. Yeah, sure, I'm going back to other stuff. Let me tell you this important thing before I move on. Interesting. 56, derivative of 56 versus derivative of 56x versus derivative of 56 plus x. I like showing this kind of like a note. What's the difference? Derivative of a constant is 0. I just mentioned that. That's not a secret. But somehow when the constant is multiplied by x, now it stays. So it survives if it's multiplied by x or any unknown, because now it's a rate. This is a constant, this is a rate. That's the difference. Whatever is multiplied by unknown is called a rate. So it's rate of change. It stays there. I like calling it, it's like a sticker. It sticks to unknown, so it survives. But if it's not stick to unknown, it's isolated. Isolated. Then it's still a constant. 0 plus 1, which is 1. Do you know why derivative of x is 1? Because it is. That's not, I'm not gonna explain. I'm gonna explain instead, but I really like this joke. Because it is. Just deal with that. Okay, I'm coming down. So it's still power rule. It's x to the 1 prime. Power rule says 1 goes down, x to the 1 minus 1, but y minus 1 is 0 and x to the 0 is 1. X to the 0 is 1. Usually people just remember the derivative of x is 1. It's just easy to remember than knowing the formula. So this, I would say, is important. Let's see, limit of this and that. C, oh, I found, there was a C here. I find the C. We did that, continuity. Very good. Let me see what else I want to show before we go to the requests. Oh, did you figure out this like a weird thing? I think it's 1.6. Number 26 in the review. Did you figure out this interesting? C of t equals 44t 2 plus 11t. This is the easiest example to have, unless you freak out. It asks you what happens when the concentration, find. It says, what does concentration approach as t approaches to infinity? Such a bad English, I think. Find C as t approaches to infinity. So there's a whole background story for this. As a mathematician, I don't like reading a lot of English stuff, especially because English is not my first language. If it's not your first language, that's what I'm trying to explain. Trying to see the idea fast. Don't have to go down into this meaning behind the problem. I mean, they want to show applications, good for them. But it's exam, like the timer is going and they think that's gonna like make you better at understanding concentration growth on the exam. No, you want to get a good grade, that's it. I'm totally supporting that. So it says a population of organisms in thousands grows after t minutes according to the function. Find what happens when t goes to infinity. Then you just set t to goes to infinity, that's it. T goes to infinity, find the leader of the top, find the leader of the bottom. Compare the speed. The speeds are the same. The answer will be the ratio of the leading coefficient. You're done. It's the easiest problem to have if you know what to do. So that's, I wanted to make it clear. If they give you some kind of different backstory, just keep reading all of this. Look at the function and look what's happening. Check the question right away. Find what the question is saying. It says what's happening in infinity. You don't have to care what's actually the problem is, but it sounds kind of lame, but it's better this way on the test. The answer is 4,000. Oh yeah, of course. Jeremy is right. If it's in thousands, then that's true. The answer is 4,000 because apparently it's in thousands. If you make this mistake on a test, I will give you full credit. I don't mind at all. I feel like that's a very bad catch to do. Yeah, the English language stuff, exactly. You're right. So if I see that kind of stuff, I'll give full credit for this. So people saying interesting stuff in the chat that we are not allowed to take honor logs on Surface and iPads. That's not because of me. It's just the school forbids it. Yeah, it's in the syllabus, and the syllabus is given by the school. They keep adding more rules. So this year, the syllabus had like 2 extra pages at the end, for example. But it's mostly about copyright and selling my amazing exam reviews for money on the check. They mentioned that. But yeah, I would love to allow you everything. But no, they don't like Surfaces and tablets, none of this Apples. So who knows? Who knows why? But okay, why is it 4,000? Because it says it's 4,000 units. And then in the book, in the problem, it says units are in thousands. So that's why. Don't be bothered by this too much. So the answer is 4, but then if you read the application problem. So there is a review page online. Yeah, so I will show you later that there's a Canvas, and Canvas has everything there. I'm very known for making amazing organization in Canvas. I give you notes, my lecture videos, everything. There was also a question here, why A is the same as f of x? A prime. Oh, yes. Very good question. Anything prime is derivative. So if that was the question, that's derivative. I actually have a cool note here I prepared. We did this. See, I knew I have it somewhere, but we already did that. Fine. This one, the derivative. You don't have to write it down. I'll give you this note or take a screenshot if you want. But derivative has different meanings, especially if you find this like applicational problems. They ask, find the rate of change. Yeah, they wanted to find derivative, f prime. Find the slope, find derivative. Tangent line, you find derivative first, and then you build the equation with tangent line. So those are the most popular things we're going to be asking to do in calculus 1, 2, and 3. So it's just like basically gonna keep stalking you. How fast something is changing, how fast the car is driving, how fast the bacteria is dividing. That's derivative. For business students, marginal profit, marginal revenue, how fast the revenue is changing. That's what it means. Instantaneous rate of change, also derivative. If you see per, miles per hour, that's velocity, that's derivative of speed, derivative of distance. Slash, that's also per. So miles per second, minutes, miles per second, or liters per minute, whatever. That is change, derivative. And also velocity or speed. Those are not the same things, to be honest. If you do take physics classes, you know. But in general, that's derivative. It just has a little bit different meaning behind. One has a sign and the other one doesn't have a sign. Can speed be negative? Can velocity be negative? So one can, the other one can. Not very important right now. So I use a Surface. I used to pre-calculus. Honor log was fine. I think should not work. You can try, I guess. Try if it works. Just make sure you log out with all the tabs from the internet and stuff. What's the difference between the relationship limits and derivatives? So I think I can show you this. This like I just was teaching it today, and students really liked it. Where's my derivatives? Oh, I just saw it. Yeah, I was just teaching it. I think this question was asked in the chat. The connection between derivatives and limits. Here you go. Without the limits, this is also called average rate. So let me show it like this. Change in y, change in x. So without the limit is the slope of a secant line. Sometimes it's also an average. What's happening on average? What is your grade on average? You take all the exams, sum them together, and divide by the number of exams. That's the average grade on the test you have. But what if I want to know how much I improved right now on this exam when I want to compare to the previous exam? That's called instantaneous rate of change. Instant, at the moment. But what does it mean to be instant? Well, I want to shrink the time interval to nothing. So to have instant change. There's a very cool phrase here. I start with my class with it. So it's average versus instantaneous rate of change. Average has no limit. Instantaneous has a limit. When you are driving a car, the officer stops you and asks you, do you know how fast you were driving? And the driver says, I don't know. Well, of course you do, liar. Officer says, you're driving 95 miles per hour. And the driver asks, but I haven't been driving for an hour yet. How do you know that? I was driving for 25 minutes. That's the cool part here. How does the speedometer, this device the officer holds, knows that you were driving with a speed 95 miles per hour if you did not drive for an hour? The average gives you some average speed, but instantaneous gives you the instant speed. How to find it? You find a little bit before and after you pass the policeman. That's the change in the denominator. So this is what the idea of the derivative is. Choose the interval. dx, usually it's called delta x, is a small change in time. The policeman is holding the device. You are passing. This is like a couple seconds before and after you passed the device he's holding or she's holding. So you choose a time interval. It's small. It's so small that we will make it go to 0. Find the row change. That will be change in your outputs. Your speed when you passed the policeman and your speed before you passed. Find the rate of change. So you divide by the 3 seconds. For example, it took you 3 seconds to pass the policeman. Probably less than that, but whatever. That is not enough. I don't want a 3 seconds. I want a 0.0001 second. I want a 0.0001. Make the model perfect. The moment you make the model perfect, it gives you the definition of derivative. Derivative is instantaneous rate of change. So now the policeman knows that at this instant moment, you were driving 95 miles per hour, even though you did not complete the whole hour. Hope like that kind of makes sense a little bit. Oh, tangent and secant line thing. Yeah, can you briefly explain the relationship? I did that. Let me check my notes if I have anything. And also, I think Tyler was sending me something in the email. Check. If you could go over this. Okay, let's see. Determine whether or not f derivative exists. Oh, you know this x sine 4 over x thing? Yeah, I see what it asks about. It's not going to be on the test. It's actually interesting. It uses the squeeze theorem, so you can make a video on that. But he's asking, okay, now everyone wants to know what I'm talking about because, right, only Tyler knows. Everyone should just ask Tyler now. Clean exam reviews. Here they are. That's my beautiful note. I love my Surface Pro because all the notes are very nicely organized. This is the problem is x sine 4 over x and 0. Does derivative at 0 exist? So x is not 0 and then x is 0. That's not going to be on the test. It's too complicated. It's nice for homework, but you need to use squeeze theorem to prove what is happening at 0. So by the definition, you need to check if the limit f of x plus h minus f of x blah 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 over h goes to 0 exists. Does this limit exist? Derivative exists. Doesn't exist, doesn't exist. So in some cases it exists and in other cases it doesn't exist. It's not very obvious, but they use squeeze theorem quite often. So use squeeze, double Z? I don't remember. Theorem. Do you know the squeeze theorem is called sandwich theorem in America? And in Soviet education, which I got, right, Ukrainian old education, they called 2 policemen and a drunken guy because the policeman on the left-hand side is a function f. Well, in this case, f is in the middle. There's a function like g and the function h. The 2 policemen, they grab the drunken guy, which is f, and squeeze it between each other. And now they're taking him to the police station. So since G goes to police station, which is limit L, and H goes to police station, which is limit L, F doesn't have a choice because he's drunk and taking care of policemen as they go to the police station L. So that's how I learned it as a 2 policemen and a drunken guy theorem. That's the idea. Okay, so hope that is satisfying your satisfying this question. Let me check another question. Good. Yeah, maybe post it in the inscribe and I'll ask there. And then someone asking more questions. Taking, oh, that's my in-person class. They will figure out, they're fine. Online, the online students have exams. That's more important. So Harrison is asking I just went through this problem. Yeah. So you're asking about the problem 4 over x. I did it. I just went through it over here. So you can check my notes in the video. Here you go. You have 4 over x. I have 5 over x. So I did that. That's good. Okay, very good. And then 2.1, number 7. Let's see. One number 7. It has 8 problems. Number 7 is, oh yeah. Oh, we did that though. So this one we just did, it was here. Let me show you. With the conjugating. Here it is. This, it's the same thing as this one. This one has 2 square roots, but yours has 1 square root. So 2.1 number 7 is kind of the same thing as this one. I probably did number 6. Oh no. Yeah, I did the other one, number 8. Yeah. So just follow the same steps. It works really well if you do that. That's good. Doing quick review on mx plus b derivatives. Yeah, I'll just post this one in the forum. I will solve it there because it's more or less the same. Let me check just a second before we move on or quit. Let me see if this is all I wanted to show. So I showed you limits of cosine at infinity. I was thinking that was important. And the graphs and the conjugate. Lots of limits at infinity, limits at the number. Fractions. This is good. Plugging little numbers. Oh yeah, this is the one. Did you do the problem with the ball thrown straight up? Lots of people asked about it in the forum. What to do when the ball is thrown straight up in the air with initial velocity, blah, blah, blah. We do that one. I think it's, yeah. Oh, I have it in the review. But it's not. Those applicational problems, you need to expect them on test. That is from the engineering department. They told us not to be too theoretical and then start throwing into those applicational problems. Nobody knows how to do. And we will have to kind of deal with that because that's what I said to do. I don't see it. Oh, the jump is good. No. I think it's 2.1. Let me find this ball question. Here it is. I found it. It's 2.1 number 2 in your homework. Going here. So some people ask about the mx plus y equals mx plus b in the chat. Y equals mx plus b. I have lots of videos on this. So let's probably just watch the videos. I solve lots of stuff. I show very good steps. Actually, today I was teaching in my class and I'm posting videos from all my classes. So you can watch it too. 2.1 and number 2. So a ball thrown straight up into the air. Okay, going up. Initial velocity. Initial velocity can be seen as v at 0. It's given as 95 feet per second. Look at that, feet per second. Its height in the feet after t seconds is given as a function. So y equals 90. 5t minus 16t squared. Find the average velocity. Period belonging when t equals 2 and lasting. What's like English word? Lasting. Okay, fine. Find average velocity. Average velocity doesn't have a limit in it. So remember, average. So velocity is derivative. Yes. But because it's average, we're not talking about limits here. We're talking about just the fraction inside of the limit. Just forget about the limit. Average velocity when t equals 2 and after, that's what it means, lasting. I did not understand it, to be honest, at first. It wasn't lasting. Could use a bit easier language for people like us. So it's already, life is already too hard if you need to translate English in the exam. 0.1 seconds. They want you to use the original formula, which is f of, there's so many ways to explain. So for example, f of t, we don't have x here, we're using t, time, plus h minus f of t. So instead of x, they're using t because it's time, divided by h, right? So h here is this 0.1 second. And then it will be 0.01, 0.001, A, B, C. So let's write it down. It will be f at t. What kind of t they're talking about? Not just a random t, but t equals 2. So let me write down. Given h is 0.1, t equals 2. So I will have t, 2 plus 0.1, just add up right away. You don't have to write it down like this, minus f at 2, dividing by h, which is 0.1. And then they're making this interval smaller and smaller and smaller, which is exactly how limit is created. Approximately 29.4. Second question says, yeah, the interval is too big. 0.1 is too big. Let's have 0.01 second. That is your new h. So you repeat the whole thing. F at 2. Well, okay, let's just do it like this. 2 plus 0.01 minus f at 2. All over 0.01. That is approximately 30.84. If your numbers match, just solve your homework. And then third one is, guess what? It's even smaller. So 0.001. That is my new h. And blah, blah, blah. And then we need to guess where it's all going. I guess I should write it down. Where is it all going? What's the point of this? Oh, did you know how I got those numbers? I just realized I should have asked. That means I'm plugging all of these numbers. The 2 is always the same, so you just calculate once. But I'm plugging it all into the function. Here's my, they gave it as y, but actually it's f of t. F of t, that's more professional to write it down as f of t. I keep plugging it there, and I keep plugging this 2.1, 2.01, and 2.001. I keep plugging it into the function to calculate the number. And the next number ended up to be 30.984. So I told you, you approximate till whatever they match, which is, well, they only match at 30. But, oh, you don't approximate till they match. They match not from the left and from the right, but we only do it from the left. So you just take the approximation. 13.9. So let's just round it up to 31. The more you take 0.000, I can even take 0.00001, and probably it's going to be 31, approximately 31. Probably it's going to be 30.9999999. So that's how you know. Answer 31. The answer says we guess the instantaneous velocity at t equals to is 31, since the previous result seems to be approaching that number. So funny, this is like just different problem. I don't like this problem. Okay, the equation, find the equation of tangent line to the curve. I definitely just post video, you can watch that. And we just did it today, so in my class. So it's that I even have a like very fresh example. But I have lots of videos on that. Good. Let me check the chat, but I feel like I feel very satisfied with this review. So let's see. Is that the same as the answer formula f of x minus f of a? Yes, the formula is the same. I mean, the formula, the knowledge is the same. It's just, it's written a different way. F of x minus f of a all over x minus a. The thing is, here they do 2 minus, in this problem, it will be harder to use this formula. So x, I remember we defined h as x minus a. That's how the next formula showed up. That's why, well, actually it is plus. So I would use the formula we just used. But yes, you're right. There are several formulas we gave you. Change in output versus change in input, and you want the input to shrink to 0. So you don't have to do anything with y squared, y t2, and yeah, I will not use this formula. Use the one with the change. That is because they give you this lasting idea. It lasts for 0.1 second. So that is original 2 plus whatever they want me to last. They want to last 0.1 second, the ball flying in the air. So I think that's why when they do this additional thing, then it's h. When they do compare the next one minus the previous one, then it's going to be y2 minus y1. Yeah, that's how I would explain it. Kind of depends on the problem. Well, that's why we have this homework example, so you know which one to expect. Why I had to write down the long formula? Well, that's because we all do that first. We always expect everything hard, and that's why the simple stuff becomes hard too, because we don't think it will be easy. So a and x are confusing. Yeah, I agree on that. So I will remember this way. A is the point, usually. The point where to look, where to find, or where we're looking at, where to find something. Usually it's f prime at a. So a should be fixed number. Sometimes a is called x sub 0. That's what probably confuses you. X sub 0 or original, first one. So that's how I remember it. Then x is x, don't touch it. X is unknown variable. H is a small change in the input. And the input in this case was time. And that's why it was so small, because we had, I actually can explain it this way, I just realized. We had f of 2.1 minus f of 2 divided by 2.1 minus 2. That is how we get 0.01. So it is the formula you just asked about. Yeah, it's the same thing as the formula of f at x minus f at a all over x minus a. It's the same thing. Like, so let me put it in something. Let me put it in like fat umbrella, fat rainbow color. So it's the same thing, if you want to see it this way. The denominator is x minus a, but x is 2.1 and a is 2. That's why it became 0.0. But by the definition, h is that thing anyway. H is x minus a. And that's why we can just use that as a change. Good. That comment was specific to the 7 problem 2.1. Yeah, post that in the forum. I will check that too. Okay, very good. Look at that. We did lots of stuff. I'm very happy about this. I think if you practice these things I just showed you, you should not fail the exam. I promise you. The best way practicing these problems is, oh, someone also reminded me to do, at the very, very beginning, they said it's hard to differentiate sine and cosine. Let me show that too. But the best way to practice is to watch this video, pause, when I write down something, and that's what I'm going to do right now. I'm going to write down one more example. It's going to be last example. Find a derivative. Find f prime if f is, I had it from the homework somewhere here. It is, let's do 5 cosine t over 3 plus 2t minus 3, like so. Oh, let's put sine, 3 sine t. So we have both. So when you rewatch this video, which I will be posting in 2 hours, because it takes 2 hours to create a 2 hours video, 2 hours long video. Pause right now when you're watching it and do it by yourself. When you finish doing it by yourself, click play and see where you messed up, or you did not mess up. Then it's amazing. Redo as many times as possible. Basically, watching someone doing work for you doesn't really help a lot. It's like you're watching someone do push-ups. Well, it's time for you to do push-ups yourself. It doesn't help you to learn how to do push-ups if you just keep watching someone doing it. That's how it is in math. Now let me write down the formula. You just need to remember, sine is a very normal behaving function. You take the derivative of sine, it gives you cosine with no negative sign. I also like to say it's normal because sine at 0 is 0, like it's expected. Sine is an odd function, so that means sine at negative gives you negative. Sine at minus x gives you minus sine x. Very normal behaving function, and that's how it helps to remember the derivative. Cosine is the one that's weird. Cosine also gives you sine, but with a negative sign in front of it. So basically, cosine and sine give you each other when you differentiate them, just with negative sign difference. And why cosine is a weirdo? Because if you look at the cosine at 0 is not 0, it's 1. Cosine at minus x swallows the sine. Like, what is going on here? That's how I like to joke about it. Sine is a normal dude, so it gives you plus cosine when you differentiate. Cosine has always been a weirdo, so it gives you minus when you differentiate. This like harassing cosine function over here. So derivative of 5 times cosine t over 3. 5 over 3 is like a sticker, it stays. Because it's attached to it. It sticks to the function, so it will survive the differentiation. It's a rate. What I did here was I just put them together. Now you take derivative of cosine. Derivative of cosine, just like I mentioned, is minus sine t. Plus derivative of 2t gives you 2. Minus derivative of 3 sine t gives you 3 cosine t. That is the answer. Can you do that? Yes, you can ask me, should I simplify? Should I rewrite it as minus 5/3 sine? No, you should not. If it's exam, just type it in and move on. Don't waste too much time. Besides, the more you write, the more chances you'll make a mistake or lose a negative sign or something. So just write down the first way, but don't forget the parentheses everywhere. And sometimes I think it likes parentheses of t also over here. So type it carefully. There's a button on your homework and exam called preview, I think. And it tells you if your rotation is correct. So do that. That's my recommendation. When you watch the video, pause and solve everything by yourself. Solve each problem by yourself. And then you feel confident. The other way to do it is to time yourself. Time for 1 hour. I know exam is 2 hours long, but it's very hard to imitate 2 hours exam. It's just too exhausting. Do at least half an hour or 1 hour. Time yourself. Put away your notes. Make it stressful. Mute your phone. Close the door. Let your siblings know that they do not bother you for finally. And then do it. Choose 10 problems and go over those 10 problems. Timed. Stress yourself out on purpose. Then on the test, you will feel better. So read my announcement called Test Anxiety. I have like lots of nice suggestions there. And students tried them and it worked for many people. It doesn't work for everyone. It depends on the person. But it's a suggestion to chew a gum with specific flavor when you prepare that will calm you down. Have aroma oils in the room since you're taking them at home. And so on. You cannot listen to music though, and you can't wear headphones. That's unfortunate. And you cannot have a cheat sheet, and you cannot have a formula sheet. That's super unfortunate. I wouldn't allow formula sheets if I were in charge. And I was actually arguing about it for 5 years, and it did not really go through the administration. They just do not like formula sheets. It's super unfortunate. Good job, people. Thank you for coming. I think there were so many comments, 80 comments. I will give you all the notes, so don't be afraid. People asking to go back. All the notes, everything you need to succeed. I post everything in modules, everything you want from me. My job is to help you as much as possible. And then, fingers crossed, I always hope people do well in tests. And everyone do well in tests, you feel happy. I feel happy. It's amazing. So, thank you, people. Have a good job for coming, staying for so long. Lots of people came. High respect to you all, that you spend your time. Don't forget to finish your homework by tonight. Good luck on the test. And don't stress out too much. Just inhale, exhale, have enough water, charge your phones, not the phones, charge your laptops, computers, and you will do good. Have a good night. And stop.